Hello, guys, welcome back to Crack Easy, the place to learn how to crack easy exams. You are with me, Abhisha. Today, I'm going to share the detailed solution of GATE 2008 and 2011 questions on Fourier transform. Hope all set to get started. The first question I have for you is from GATE 2008. The signal x of t is described by x of t is equal to 1 for minus 1 less than or equal to t less than or equal to 1 and 0 otherwise. Two of angular frequencies at which its Fourier transform becomes 0 are. Four options are given. Option A pi 2 pi, option B 0.5 pi 1.5 pi, option C 0 pi and option D 2 pi 2.5. Here we have a continuous time signal x of t and we are asked to find out angular frequencies at which the Fourier transform of this signal x of t becomes 0. So what we need to do is first we need to find out Fourier transform of this continuous time signal x of t and then determine the angular frequencies at which the Fourier transform becomes 0. As I just said, the continuous time signal x of t is given in question as 1 for minus 1 less than or equal to t less than or equal to 1 and 0 otherwise. The Fourier transform x of j omega of a continuous time signal is mathematically defined as x of j omega is equal to integral minus infinity to infinity x of t e raised to minus j omega t dt. Now you look at this x of t. You can see it is having non-zero value only for the time interval minus 1 to 1. Correspondingly, we can change the integration limit minus infinity to infinity as minus 1 to 1 and for that time interval x of t is 1. Hence we get x of j omega as integral minus 1 to 1 e raised to minus j omega t dt. By performing integration, it becomes e raised to minus j omega t by minus j omega minus 1 to 1. After applying upper limit and lower limits, we get it as 1 pi minus j omega into e raised to minus j omega minus e raised to j omega. I hope you all know that e raised to j omega minus e raised to minus j omega by 2j is defined as sine omega. By using this relation, we can write e raised to minus j omega minus e raised to j omega as minus 2j sine omega. Correspondingly, x of j omega becomes 1 pi minus j omega minus 2j sine omega, or we can write x of j omega as 2 sine omega by omega. Thus we obtain the Fourier transform of continuous time signal x of t. What is our next task? Our next task is to find out angular frequencies at which this Fourier transform becomes 0. Here we have a sine function which becomes 0 at omega is equal to pi and 2 pi. Correspondingly, we can write the angular frequencies at which x of j omega becomes 0 are pi and 2 pi. Thus, our answer is option A. Let me now take you to next question. It's from GATE 2011. The first 6 points of the 8-point DFT of a real valued sequence are 5, 1 minus j3, 0, 3 minus j4, 0 and 3 plus j4, etc. The last 2 points of DFT are respectively. 4 options are given. Option A 0, 1 minus 3j, option B 0, 1 plus 3j, option Z 1 plus j3, 5 and option D 1 minus j3, 5. So here we are given with first 6 points of an 8-point DFT and we are asked to find out the remaining 2 points. In fact, there is a relation between different elements of an 8-point TFT, and we are going to use that for determining unknown quantities. That is, in an 8-point TFT, x conjugate of 1 can be equated to x of 7, x conjugate of 2 to x of 6, x conjugate of 3 to x of 5, and x of 4 to x conjugate of 6. The first 6 points of the 8-point TFT are given in the question. They are x of 0 is equal to 5, x of 1 is equal to 1 minus j3, x of 2 is equal to 0, x of 3 is equal to 3 minus j4, x of 4 is equal to 0, and x of 5 is equal to 3 plus j4. The desired quantity x of 7 can be equated to x conjugate of 1. X of 1 is already given in question as 1 minus 3j. Correspondingly, we get its conjugate as 1 plus 3j. On the other hand, the desired quantity x of 6 can be equated to x conjugate of 2. X of 2 is given in the question as 0. Correspondingly, its conjugate becomes 0. Thus, we obtained our desired quantities are 0 and 1 plus 3j, or our answer is option B. Hope you understood this problem perfectly. So, we are at the end of this session. If you have any doubts, please do let me know in the comment section. Thanks for watching. Thank you.